Allotropes of carbon. Graphite. In graphite, each carbon is connected to only 3 atoms. Since carbon must form 4 bonds, one of the 3 bonds would be a double bond. This gives the average bond order of 1.33. In graphite, carbon atoms are sp2 hybridized, with each carbon atom having trigonal planar geometry. The graphite structure has layers of infinite sheets stacked one on top of another. The layers do not exactly lie on one another, but instead are offset. For example, alternating layers are equivalent. There is no bonding between the layers. Therefore, graphite is a two-dimensional network covalent solids, as the chemical bonding occurs in only 2 dimensions. Diamond. In diamond, each carbon atom is connected to 4 other carbon atoms in a tetrahedral arrangement. Three such tetrahedrons are joined to form a puckered membrane structure. Thus, structure is capped by a 4 tetrahedrons to form a structure that is itself a large tetrahedron. Diamond is such an example of network covalent solids. That means it has covalent bonds which extends in 3 dimensions throughout the structure. Diamond is essentially a large molecule. As result, diamond is a good conductor of heat and is the hardest substance known. Its structure can only be visualized as a cubic. By tilting and rotating the cube, the orientation can be seen as a tetrahedron shape. Repetition of this cube also generates the diamond structure in an array. Fullerenes. Fullerene structure consists of carbon atoms arranged into spherical molecules. Like graphite, each carbon atom is connected to 3 other carbon atoms. However, it consists of 5-membered and 6-membered rings. The most common fullerene is the C60, also known as the buckyball. This molecule consists of 12 5-membered rings and 26-membered rings arranged in spheres resembling a soccer ball. Another is C180, C240. Both are spherical. Review. Diamond. In diamond, each atom is bonded to 4 others and overall structure is tetrahedral or cubic. Diamond is a network covalent solid, which means it has covalent bonds extending throughout the structure in 3 dimensions. Graphite. Graphite consists of infinite 2-dimensional layers of carbon atoms bonded into 6-membered rings. Each carbon atom is bonded to 3 others by 1 double and 2 single bonds. Average bond order is 1.33. There is no chemical bonding in between these layers. That is, graphite is a 2-dimensional network covalent solid. Fullerenes. It is a molecular substance where carbon atoms are arranged to form spherical molecule. Each atom is bonded to 3 others as in graphite. The fullerenes contain both 5-membered and 6-membered rings, and 5-membered rings are responsible for the curvature.